Hello everyone, good evening. So here we shall solve some more KCET previous year questions on the chapter aldehydes, ketones and carboxylic acids. So any doubts if you have in any steps, then please write that in the comments section. We shall obviously clarify them. And please install our Sapience Education application where we shall upload some important homework questions based on the previous year KCET exam. So here it is told that iodoform can be prepared from all except. So iodoform means CHI3. So it can be pre uh, prepared from all compounds. So iodoform it can be prepared from all those compounds, containing the CH3CO group or CH3CHOH groups. So for the first option, option A, it is told butane 2 on. So it is butane 2 on. So yeah, it contains the CH3CO group. So it can be used to pre prepare iodoform. Then option B, it is told acetophenone, which is CH3CO, then which is acetophenone. So it also contains CH3CO group at the end of the chain. So it also can be used to produce iodoform. And in option C, it is propan 2-ol. So this is propan 2-ol. So it also contains CH3CHOH groups. So it also can be used to prepare iodoform. But in option D, it is told propan 1-ol is CH3CH2 CH2OH. So it does not contain the CH3CHOH group or this CH3CO group. So it can't be used to prepare iodoform. So option D is the correct answer. Then it is told acetic acid, which is CH3COH, is treated with calcium hydroxide. So acetic acid is treated with calcium hydroxide and the product so obtained is subjected to dry distillation. The final uh, product is, so here it will form calcium acetate, which is CH3CO whole twice Ca, plus it will form 2H2O. So it will form calcium acetate. So when the calcium acetate is subjected to dry distillation, it means that it is heated, then it will form CH3CO CH3, which is called acetone, or propanone. Propanone will be formed and CaCO3, calcium carbonate. So propanone will be formed. So option D is the correct answer. Then it is told that the distinguishing test in between methanoic acid and ethanoic acid is. So how can we distinguish in between methanoic acid, which is HCOOH, and ethanoic acid, which is CH3COH? How can we distinguish in between these two acids? So the methanoic acid, or I can tell the formic acid, it contains alpha hyd hydrogen, means it contains COOH group and here this H, so it contains alpha hydrogens. So it can behave like an aldehyde also. Can act it can act as an aldehyde also. But in case of the acetic acid, which is ethanoic acid, here it contains CH3COOH group. So it is not containing any al it can't act as an aldehyde, but formic acid can act as an aldehyde as well as a carboxylic acid. So hence formic acid can give tolerance test, can give positive tolerance test, but the acetic acid, it can't act as an aldehyde, so it can't give tolerance test, can't give tolerance test. So it means option A is the correct answer. So we can use the tolerance test to distinguish in between formic acid and acetic acid. Then here it is told benzene carbaldehyde. Benzene carbaldehyde, which is this, it is reacted with concentrated sodium hydroxide solution to give products A and B. The product A, it can be used as a food preservative, can be used as a food preservative, and the product B is an aromatic hydroxy compound. So it is an aromatic hydroxy compound where the OH group is linked to sp3 hybridized carbon. Here the OH group is linked to the sp3 hybridized carbon next to the benzene ring, next to the benzene ring. Then the products A and B are respectively. So when the benzene carbaldehyde, this is benzene carbaldehyde, when it reacts with concentrated NaOH, then it will form the products. One is sodium benzoate, is CONA plus. It is sodium. So the compound A is sodium benzoate, and it will form the product B. The product B is CH2OH, which is phenyl methanol, phenyl methanol, phenyl methanol it will form. So the sodium benzoate, so it is also called as the Cannizaro's reaction, Cannizaro's reaction, since here one molecule is reduced to alcohol and the other is oxidized to sodium salt of the carboxylic acid. So it is a kind of disproportionation reaction, disproportionation reaction, since why the same molecule, it gets oxidized also and it gets reduced also. So, and we know that sodium benzoate can be used as a food preservative, and in case of phenyl methanol, it is obviously an aromatic hydroxy compound, and here the OH group is linked to sp3 hybridized carbon, which is next to the benzene ring. So it means A is sodium benzoate and phenyl, B is phenyl methanol. So option B is the correct answer. Then it is told predict the product C in the following series of reactions. So here CH3COOH, that is reacting with PCl5, and it will give the product A, which is CH3COCl. So here the OH group will be replaced with Cl. Here, here we have COOH group. So this OH group will be replaced by Cl. Then it reacts with benzene in presence of anhydrous AlCl3. Then it will form COCH3, which is the phenyl um, which I can say it is phenyl methyl ketone, or I can say phenyl acetone, or I can say phenyl ethanol, phenyl ethanol. So which is the compound B, and the compound A is obviously C3COCl, and then this compound B, it reacts with CH3MgBr, which is the a Grignard reagent. Then it will form COH CH3 CH3, which is the compound C. So here we have to predict the product C in the following reactions. So it is uh, obviously the option D. Since why here it is told that two is this carbon is linked with two methyl groups and one OH group and one phenyl group. So option D is the correct answer. And here it is told lower members of aliphatic carboxylic acid are soluble in water. This is due to the reason is the formation of hydrogen bonds with water. So for example, if you have RCOH, which is the aliphatic carboxylic acid, so it can form hydrogen bonds with water. It can form hydrogen bonds with water. So here hydrogen bond can be formed. So it means that lower members of aliphatic carboxylic acid are soluble in water. So option A is the correct answer. Here, why it is told lower members? Lower members, it means that this alkyl group should not be very long chain. Lower members, it means this alkyl group which is attached, it should be a small chain. It should not be very long chain, so it should have a small chain alkyl group. Then they will be called as lower members of aliphatic carboxylic acid. So they are soluble in water due to the formation of hydrogen bonds with water. Option A is the correct answer. Then it is told that the reduction of ketones cannot be carried out with which of the following reagents? Reduction of ketones. So reduction of ketones can't be carried out in with hyd hydrogen in the presence of palladium. Okay, Hyd hydrogen in presence of palladium in barium sulfate and quinoline. Barium sulfate and quinoline. Since why when H2 and palladium is used, it is called as a hydrogenation re- reaction. Um, so hydrogenation can be done only for alkenes and for alkynes. Only for alkenes and for alkynes, and hence um, the ketones can't be reduced through the process of hydrogenation. So here no reaction will happen. So option A is the correct answer. Then here it is told in the following sequence of re reaction, the end product C is. So here CH3Br that will react with KCN. So KCN is the reagent which will give cyanide as the nucleophile, and this nucleophile will attack here and then it will form CH3CN and KBr. So here the compound A is ethane nitrile, and when it is hyd hydrolyzed in the presence of an acid, then it will produce CH3COOH. It will produce CH3COH, and when, which is the compound B, which is acetic acid, and then when it is reacted with lithium aluminum hydride. Now lithium aluminum hydride, it will give the hydride ion as the nucleophile. So it will reduce this carboxylic acid into alcohol. So it will reduce the carboxylic acid, which is RCOH, into alcohol, into RCOH, RCH2OH. It means it will convert it into primary alcohols. So it means that it will form CH3CH2OH, which is the end product C, which is e ethanol or ethyl alcohol. So option C, okay. Now option B is the correct answer. Then it is told that Canizaro's reaction is an example of auto oxidation. So it is a typical reaction of aliphatic aldehyde. Then it is told it is a reaction answered by only aldehydes containing alpha hydrogen, which is false. It is a reaction answered by only aromatic aldehydes, which is false. It is a reaction answered by all aldehydes, which is also false. So only those aldehydes, the rule is that only those aldehydes which do not contain which do not contain an alpha hydrogen atom will undergo Canizaro's reaction. Will undergo Canizaro's reaction. So hence it means that only those aldehydes, it means the CHO group, here it should not contain any alpha hydrogen. It means that should be like this. It should be attached to alkyl groups. So it should not contain any alpha hyd hydrogen atom. Then only it will give Cannizaro's reaction. So none of the options are correct. It simply it means that the carbon which is attached to the aldehyde group, it should not contain any hydrogen atom. Suppose for example, if I have three hydrogens with this carbon which is linked with the CHO group, it means here it has got three alpha hydrogens, 1 2 and 3. So if this carbon is not having any hydrogen atom, then it means that this aldehyde, it is not having any alpha hydrogen. Only then it will give Cannizaro's reaction. It means that this compound will not give Cannizaro's reaction, but this one, if it is attached to some other alkyl groups, it means if this carbon has no has no hydrogen on it, then only it will give Cannizaro's reaction. Okay. Then here it is told which of the following compounds undergo haloform reaction. The the rule is that those compounds those compounds which have those compounds which have got the CH3CO group which is attached to it, or the CH3CHOH group can undergo haloform reactions. So now in the option A, it has got CH3COCH3, so it is acetone. So hence it has CH3CO group, so it will give haloform uh, reaction. And in case of uh, option B, option B, it is HCHO, so it is not having CH3CO uh, group, so it will not give haloform reaction. In the option C, it is CH3CH2Br, so it is not having either the CCCO or CCCHOH group. It is not, so since why it is neither an alcohol nor a aldehyde or a ketone, so hence it will not give haloform reaction. And then in CH3OCH3, it is an ether, so it will not give haloform reaction. So it means only the option A is will give haloform reaction. So option A is the correct answer. Then it is told the appropriate reagent for the following transformation is. So here this is cyclopentane. Here we have OH group and here we have COCH3 group. And we want to convert this into this. It means that we want to remove this oxygen. So here we should use ethylene glycol, ethylene glycol in the presence of hydrazine. the presence of hydrazine and KOH. So option B is the correct answer. So here the rule is that both the zinc mercury amalgam and HCl and hydrazine NH2 and KOH can reduce the ketone group into the CH2 group, but but in case of but the rule is that in case of zinc mercury amalgam HCl, if it is used, then the HCl will will also substitute substitute the OH group, also substitute the OH group with Cl. Hence, uh, the hydrazine with the NH2 with KOH is the most effective reagent in this case. So NH2 KOH is the most effective reagent for this reaction. So simply it means that if ZnHgHCl is used, it means that it will reduce this CO group into CH2 and it will again replace this OH group with Cl. So it means that zinc Hg with HCl can't be used. Then it is told that reaction, in the following reaction, which is toluene, it reacts with CrO2Cl2 in presence of CS2 to give the compound X. And so here the compound X, which will be a complex, so it will be CH OCrCl2OH and OCrCl2OH. So it will be a brown colored chromium complex. Brown colored chromium complex will be formed, which is the product X, and which will again react with H2O in the presence of an acid to give the compound Z, which will be benzene carbaldehyde or benzaldehyde. So it will form benzaldehyde, which is the compound Z. So option B is the correct answer. Then here it is told which is the most suitable reagent for the following conversion. Which is the most suitable reagent for the following conversion. So here we have an alkene with CH2 with the ketone group again. So it should be converted to CH3CH CH2 COOH. Simply it means that we have to replace this methyl group with OH group. So how can we do that? So here we need to have the iodoform reaction, it means that we should use I2 with NaOH. Then it will form COO minus and Na plus 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 it will have it will form sodium iodide plus H2O. And then again when it is further if we add some acidic solution here if we add some with w- with the sodium salt uh, of its carboxylic acid, if we add some acidic solution, then we will get fine finally we will get the required carboxylic acid. Hmm. So here it means that we should use I2 with NaOH solution, which is used in the iodoform test. So so option B is the correct answer. Then here it is said that the re- reagents A, B, and C respectively are. So here CH2OH with CHO. So if we use the reagent A, then it will form CH2OH and then CH2OH. Simply it means that it will reduce this aldehyde into an alcohol. So here the reagent that should be used it will be NaBH4 with uh, in the presence of an alcohol and an acid. So it is the reagent A. And if reagent B is used, then it will give aldehyde CHO with CH and CHO. It means that it will keep this CHO and it will oxidize this alcohol. It will oxidize this primary alcohol into an aldehyde. So here we should use alcoholic KMNO4, which is the reagent B. And if we use the reagent C, then um, it will keep the alcohol group as it is, and it will reduce the alkene into alkane, and it will also reduce this aldehyde into an alcohol. So hence here we should use the hydrogenation reaction, which is H2 in palladium, H2 in palladium, which is the hydrogenation should be used. So it is the re- reagent C. So the first one is NaBH4, the second one is alcoholic KMNO4, and C is H2PD. So option B is the correct answer. Then here it is told propanoic acid, which is CH3 CH2COH, which is the propanoic acid. It undergoes HVZ reaction. HVZ reaction to give chloropropanoic acid. So it will give chloropropanoic acid. So here the product obtained is stronger than propanoic acid or as strong as propanoic acid, that we have to find out. So here the Cl, as we know, it is an electron withdrawing group. It is an electron withdrawing group. It means that it has got uh, minus I effect or negative inductive effect. So due to minus I effect, it will increase the acidity of the acid. It means here this hydrogen, it is more acidic than in the case of propanoic acid. So it means that chloropropanoic acid is more stronger acid than propanoic acid. So option A is the correct answer. Then it is told that the compound P undergoes hydrogenation in H2PD in the presence of barium sulfate to give the product Q, which again in the presence of concentrated sodium hydroxide in dilute hydrochloric acid, it will give the products R and S. Then it is told that R and S form benzyl benzoate when treated with each other. So here R will react with S to form benzyl benzoate. Benzyl benzoate, which is like this, benzyl benzoate. It is called benzyl benzoate, which will be formed. So hence, um, the pro product R should be um, CH2OH, which should be phenyl methanol plus, and the product S should be the sodium salt of the benzoic acid, C3, which is PHCO minus Na plus. So it is S and this is R. So now R and S, they are formed by the reaction of Q with concentrated NaOH. So which is again called as the Cannizaro's reaction. Cannizaro's reaction, since here one alcohol is formed and one sodium salt of carboxylic acid is formed. It means the Q should be an aldehyde. So Q should be an aldehyde, since it is reduced to an alcohol and the same molecule is reduced to a sodium salt of carboxylic acid also. So it it is this aldehyde, it is undergoing oxidation also, and it is undergoing reduction also. So hence the compound Q, that will be benzaldehyde. Benzaldehyde, use benzaldehyde, and which is formed from the reagent P. So the reagent P should be PHCOCl. Since why? When it is reacted with H2PD in the presence of barium sulfate, then it is called the Rosenmund re reaction. Rosenmund reaction, and it will form the benzyl dehyde and HCl. So it is the product Q, and this is the reactant P. So the reactant P is CH3 C6H5CO Cl. So option C is the correct answer. Then it is told that the product P is here benzyl dehyde, which is pH means C6H5CHO, that is reacting with CH3CHO, and that will react with dilute sodium hydroxide, dilute NaOH, and it is and in the presence of heat, it will produce the product P. So here what will happen that here the CO group, here we have CO group and here we have CH2, here we have CHO and here we have CH and here H2. So this oxygen will combine with H2 to form H2O, and here one alkene will be formed. It means it will be like this CHCHO, and it will form H2O. So this is the product P which will be formed. So option B is the correct answer. Then it is told that the carbonyl compound that does not undergo aldol condensation is the carbonyl compound that does not undergo aldol condensation. So the rule is that if there is no alpha hydrogen, if there is no alpha hydrogen atom in the carbonyl compound, in the carbonyl compound, then it will not undergo aldol condensation. Then it will not undergo aldol condensation. So here the first one is dichloroacetaldehyde. Acetaldehyde. So dichloro, it means Cl H CH3CHO. Okay. CH3CHO. It is dichloroacetaldehyde, and the second one is trichloroacetaldehyde, which is Cl and CHO. And in the option C we have acetaldehyde, which is CH3CHO. In the option D we have acetone, which is CH3COCH3. So in case of the option A, here we have one alpha hydrogen. Since why? Alpha hydrogen, it means the hydrogen atom which is attached to that carbon atom which is linked with the CHO group or with the carbonyl group. So here only this carbon is attached with this carbonyl group. So here it has only one hydrogen. So here we have one alpha hydrogen. So it will give aldol condensation. And in option B, in the trichloroacetaldehyde, here there is no alpha hydrogen. So it will not give aldol condensation. And in the option C, here we have 3 alpha hydrogens. So here it will give aldol condensation. And option D also, here we have 3 plus 3, 6 alpha hydrogens. So it will obviously give it will obviously give aldol condensation. So only option B will not give aldol condensation reaction since it has no alpha hydrogens. So option B is the correct answer. Then here it is told that an organic compound X on treatment with PCC in dichloromethane gives the compound Y. An organic compound X on treatment with PCC in dichloromethane, which is CH2Cl2, in the presence of PCC, it gives the compound Y. The compound Y again, it reacts with I2 in the presence of an alkali, which is NaOH. Then it will give to form a yellow precipitate, which is CHI3, which is the iodoform. Since so here it means the product Y will give iodoform reaction. Since the iodoform, it forms yellow precipitate. Um, yeah, it forms yellow precipitate of triiodomethane. This triiodomethane, which is CHI3, triiodomethane, which is CHI3, it is only called as iodoform. The then the compound X is. So it means that the compound Y should have, it means that the compound Y should be CH3CHO. Since why it should have the CH3CO group here, since it is giving the iodoform test. Since it is giving iodoform test, so hence it should contain the CH3CO group, and or it can contain the CH3CHOH group also. So now it means the compound X should be CH3, the compound X should be CH3CH2OH, which is ethanol. Since why? When it reacts with CH2Cl2, which is dichloromethane in the presence of PCC, then it will give CH3CHO, and which will form CHI3 with I2 and NaOH. So hence option C is the correct answer. Then it is told the set of, in the set of reactions, identify D. So you have to identify the compound D. So here it is told CH3COH, which is the acetic acid. It reacts with SOCl2 to give the compound A. Will give the compound A, which is CH3. Sorry. Simply when it reacts with SOCl2, this OH group will be replaced by Cl. So it will form CH3COCl, which is the compound A. And then it will react with benzene in the presence of anhydrous AlCl3, then it will form the compound B, which is mm, the compound B, which is COCl. Okay. Okay. So it will react with anhydrous AlCl3 to form this compound B, and then further it will react with HCN to form yeah, then here it will form the Cn minus ion will attack here. It will form the compound C, which is COH, and here it will have Cn CH3 is the compound C, and here one minus charge will be formed. Okay, H plus. Okay, no, Cn. This is okay. This is the compound C, and when this compound C again will react with H2O, when this compound C, which is COH CH3Cn, when it reacts with with H2O, when it is hydrolyzed, then this cyanide will be converted to the carboxylic acid. So it will give uh, C COH OH CH3. It will give hydroxy carboxylic acid. So option D is the correct answer. So it is the required compound D, and this is the compound C. So option D is the correct answer. Then here it is told that the compound A on reaction with HgSO4, which is mercuric sulfate with sulfuric acid, then it will produce acetaldehyde, which is CH3CHO, acetaldehyde. Hence, it means the compound A should be the ethyne, CH triple bond CH, which is ethyne. Since why here ethyne will be converted, it will be oxidized to CH3CHO in the presence of mercuric sulfate, and okay, so here actually it will form enol, CH2CHOH it will form, and and here it will show tautomerism. It will show tautomerism. It means that its tautomer is so it is the enol, and it can convert into ketone, which is CH3 CHO. It means that the enol will be converted into the aldehyde C3CHO. So it can give acetaldehyde. Then, so the compound A is the ethyne, and the compound B is the, it is reacting with PCC to give acetaldehyde CH3CHO. Now it means the compound B should be 1 degree alcohol, so it is CH3CH2OH. Since why here the alcohol is oxidized by PCC into CH3CHO. It means here the primary alcohols will be oxidized into aldehydes, and the compound C is converted by essential to HCl in the presence of an acidic solution H3O plus to form acetaldehyde CH3CHO. So here it should be CH3CN, which is the cyanide. So it should be CH3CN, which is ethane nitrile. So it is the compound C, which is acid hyd. So the cyanide group is hydrolyzed into the CHO group in the presence of SnCl to HCl. So it means the compound A should be ethyne, the compound B should be ethanol, and the compound C should be ethane nitrile. It means that option C is the correct answer. Then here it is told the reagent which can do the conversion is. So here CH3COOH, the acetic acid is uh, reduced into a primary alcohol into CH3CH2OH. So here I should use the lithium aluminum hyd hydride, since it will reduce this carboxylic acid into an alcohol, lithium aluminum hydride in the presence of ether. So option A is the correct answer. Then which is the most suitable reagent for the following conversion? So here it is told CH3 CH2, then COCH3, that is converted into CH3 CH2 CHCOOH. So simply it means that this methyl group, it should be replaced with OH group. So here we should first use I2 and NaOH, which is used in the iodoform reaction. Since here we have CH3CO group, so hence it will give the iodoform reaction. So here it will form the, so here first it will form the sodium salt of the carboxylic acid, which is O minus Na plus, and it will form CHI3, which is the yellow precipitate of the iodoform. So here yellow precipitate of iodoform will be formed, and then it is re reacted with an acidic solution. This salt of the carboxylic acid is reacted with an acidic solution to form CH3CH CH2 COOH. So hence the final product will be formed. It means that I should use I2 and NaOH solution with subsequent acidification. Acidification, it means that we should add some iodine, some acidic solution. So option C is the correct answer. Then here it is told that the product A. So okay. So here the reaction is CH CH3 which is isopropyl benzene. It is called the isopropyl benzene, or it is called the cumene. So the cumene, it is oxidized to form cumene hydrogen cumene hydroperoxide. It is forming cumene hydroperoxide CH3OOH. This cumene hydroperoxide is forming, and then it is acid hydrolyzed. So it is hydrolyzed in the presence of an acid to form phenol, and acetone. Will form phenol and acetone. So the here it is told that the product A gives white precipitate when treated with bromine water. The product B is treated with barium hydroxide to give the product C. The compound C is again heated strongly to form product D. Now here the acetone, here the acetone, which is CH3, it will react with barium hydroxide to give the aldol reaction. It is called aldol reaction to give CH3OH and then CH2COCH3. Simply here it means that the CH3COCH3, it will react uh, with H2CH3O. So simply it means that so here it will form OH from here. Okay, CH2, and here it will form OH, and here plus, then this one. Okay, so it will simply link with this one. This one will, okay, will link with CH2CO CH3 to form the compound C, the product C, which is called the, so its name is 1, 2, 3, 4, 5. So its name is 4 methyl, okay, and 4 hydroxy also, 4 hydroxy, 4 methyl uh, pentanone. Pentan 2-on. Okay. And when this compound C, it will again react with, so it is heated strongly. On strong heating, it will re re remove one molecule of H2O. It means there will be dehydration reaction, and here one alkene, here one double bond will be formed. Since why, here it will remove this H2O, and here one double bond will be formed, which is CH3, C double bond CH, here CH3, here CO, CH3. So which is the final compound D. And then here the compound D, its name is 1, 2, 3, 4, 5, which is its name is 4 methyl pent 3 in 2 on. And the so here the pro- product B is the acetone, and the product A is phenol. So now phenol, as we know, it reacts with bromine water to give a white precipitate. So here the phenol, it can react with bromine water to give a white precipitate, which is a tribromo derivative, which is OH, Br, Br, Br. So which is tribromo, or I can say it is 246, 246 tribromophenol, which is a white precipitate. White precipitate is formed, and HBr is formed. So it means that the compound D, which is formed, it is 4 uh, methyl pent 3 in 2 on 4 um, methyl pent 3 in 2 on. So option A is the correct answer. Then here it is told that ethanoic acid undergoes Hell-Vollard-Zelinsky re reaction, which is HVZ reaction. So ethanoic acid is the acetic acid which will undergo HVZ reaction, but methanoic acid does not. So HVZ reaction, it means that here here bromine and red phosphorus is used in the presence of H2O to form CH2Br COH. So it will give bromoethanoic acid, and so it will give HVZ reaction. Since why, in ethanoic acid, it has got alpha hydrogens. Since it has got 3 alpha hydrogens, which so these are the 3 alpha hydrogens, so hence it will give HVZ reaction. But in the case of methanoic acid, in case of methanoic acid, which is also called formic acid, here we have HCOH. So here we are not having any alpha hydrogens. Here we have no alpha hydrogens, so it will not give HVZ reaction. So it does not give Hell-Vollard-Zelinsky reaction. So it means that HVZ reaction, it will give only if it has got alpha hydrogens. So the reason is that the presence of alpha hydrogen in ethanoic acid. So option D is the correct answer. And here it is told the general name of the compound formed by the reaction in between aldehyde and alcohol is. So when an aldehyde, which is RCHO, that reacts with an alcohol R dash OH, then then the compound formed is. So here we have RCOH. So here what will happen, that it will form RCOH and OR dash. Simply it means that here H plus will be formed and OR minus it will attack here, and this one will go here and it will form, and this H plus it will come link with this O minus. So simply here it means that first it will form O minus, then here OR dash, and here H is there, and this H plus will link with this O minus to form okay, RCHOH OR dash. So simply it means that it will form an ether with an alcohol, and then further with it will react with R dash OH to form RCHOR dash OR dash. It means that it will form an acetal. Acetal will be formed. It means that here two alkoxy groups will be attached to some alkyl group. So when two alkoxy groups are attached, then it is called as an acetal. So it is the general name of that the compound which is formed. So option D is the correct answer. And here it is told that the reaction by which benzaldehyde cannot be prepared is, the reaction by which benzaldehyde cannot be prepared is, so toluene, the first one is toluene CH3, when that reacts with CrO2 Cl2 in CS2 in the presence of H3O plus, then obviously it will form benzaldehyde, and in option B it is benzoyl chloride, which is COCl, and it will react in the presence of H2 PD and BaSO4, which is called as the uh, Rosenmund reaction. Then it will form the benzaldehyde again, and then in the option C it is benzene plus CO plus HCl in the presence of anhydrous AlCl3. Here also it will produce benzaldehyde, but in the option D it is told, that benzoic acid, which is COOH, benzoic acid, it will react in the presence of zinc amalgam and concentrated HCl. So here there will be no reactions, since why zinc amalgam and concentrated HCl, it is used to reduce the al aldehyde. Here it is used to re re reduce the aldehyde or the ketone group into the CH2 group. The aldehyde or the group, it means that C double bond O group that is used to reduce it to CH2 group. So it can't reduce the carboxylic acid. So hence option D cannot be used to form benzaldehyde. Here benzaldehyde will not be formed. So option D is the correct answer. Then this asks that the test to differentiate in between pentan 2 on and pentan 3 on is the test to differentiate in between pentan. Now pentan 2 on, it is 1 2 3 4 5. This is pentan 2 on this, and of course these will be CH2, this is CH3. So this is pentan 2 on, and we have pentan 3 on, which is CH2 CO CH2 CH3. So this is pentan 3 on. So how can we reduce or how can we uh, differentiate in between pentan 2 on and pentan 3 on? So here the rule is simply by using the iodoform test. By using iodoform test, since why? In case of pentan 2 on, it has got CH3CO group which is attached at the end of the chain, and in pentan 3 on, it is not having the CH3CO CH3CO group at the end. And as we know that only those compounds which have CH3CO group at the end of the carbon chain will give the iodoform test. It will give iodoform test. So hence the pentan 2 on, it will give iodoform test. It will give iodoform test, and pentan 3 on will not give iodoform test. Will not give iodoform test. So simply by using iodoform test, we can differentiate in between pentan 2 on and pentan 3 on. So option B is the correct answer. And here it is told the IUPAC name for this compound is CH3CO CH2 CH2 COOH. So it is obviously the carboxylic acid, and this is the uh, ketone. So now as we know that carboxylic acid has got higher seniority than the ketone group. It has got, so the carboxylic acid is more senior than ketone. So hence for this ketone group we should use for this. So the ketone will act as the substituent. It means we have to write it in the prefix, and for carboxylic acid we should write it in the suffix. So hence the name will be, it will be 1 2 3 4 5. So it will be 4 4 oxo pentanoic acid. It will be 4 oxo pentanoic acid. So option B is the correct answer. So it is the required IUPAC name of this given compound. So hope all of you understood the solutions of all these questions based on the previous year KCET exam on the chapter aldehydes, ketones and carboxylic acids. So still any doubts if you have, then please write that in the comments. We shall obviously clarify them. And also please install our Sapience education application, where we shall upload some important previous year questions based on the KCET exam, which shall be obviously helpful for your exam. So thank you everyone. Bye.